Well, it looks like we are at acid and bases now. Here we go. So, following the rules to naming acids and bases, kind of a quick summary here. When you have an acid without oxygen, so without oxygen, the prefix will always be hydro, and then at the end, you're going to have IC. Okay, so here an example of that one. Here in 1C, and HBr. Uh, so we always start with hydro in these. There's no oxygen found in this one. And at the end is going to be IC, and we're going to put acid at the end of that. And Br stands for bromine, so you're going to take off the I and E. And bromine is really bromide. So an IDE element like that, we're going to take that and take the IDE off of there. And we're going to add the IC onto it. So we have hydrobromic, and then we have acid at the end of that. We have another example of that in G. And we have hydrogen, and we have the fluorine. Well, the rule is we're going to start with, if there's no oxygen here at all, so we're going to put hydro in the beginning. Okay, that's important. And then we're going to have the IC at the end. Okay, and then we're going to have acid, and in the middle will be fluor, hydrofluor, and then it would be ic acid, hydrofluoric acid. So that is another example of an acid without oxygen in it. And we have the same thing here in B. We have the hydro again, hydro at the beginning, and Cl stands for chlorine, or we have chloride, so it's going to be chlor, and then we have the IC at the end, hydrochloric, and then acid at the end. Okay, so that's how you solve those kinds of naming problems. Now, if you do have one with oxygen, and that's the symbol for with oxygen, then you're going to have to just add the IC on the end. And we do not use the hydro. So there's no hydro in the beginning for the ones that have oxygen. So if we look at E here, we have NO3, and we name that according to the anion, and NO3 is the anion. And this is why it's important to have your polyatomic ion chart. And you look for NO3. NO3 is nitrate. And so the ATEs will always turn into ICs. So we have nitrate. So instead of saying nitrate, we're going to say nitric. So we always name it according to the anion. We don't use hydro at all. So this would become nitric acid. Okay, no hydro whatsoever. We have this one. We look at the anion. There's oxygen here. SO4 is a polyatomic ion. So we look for SO4 in our polyatomic ion chart, and we see that it's sulfate. Well, sulfate has the ATE at the end. And so the ATE now becomes the IC. So we're not going to use hydro at all. We're going to say sulfuric acid. Okay? This one I'm just going to give to you. This is acetic acid. You're not going to see that in your final anyway. We go to F. We have CO3. CO3 is carbonate. Carbonate, ATE turns into IC. So we don't use the hydro prefix. And so this turns out to be carbon, right? Instead of carbonate, it'll be carbonic, IC, acid. Okay? Simple way of naming acids. Now, there is one more we're talking about, but we're going to do that a little bit later. So this one down here, we're going to name these. These are bases. And the way we can tell they're bases, because we have the OH on the end over there, that's hydroxide. And the way that you name bases like that, when you see the formula, is simply just writing the name of the metal in the front, which is sodium, and then the name of the anion, which is your hydroxide, so you write hydroxide. Sodium hydroxide is your base. We see the OH at the end. Same thing here in I. We have calcium, So we just write the name of that metal, and then we look at the other end, we have hydroxide. Doesn't matter if it's in parentheses with the 2, you just write the word hydroxide, and that's how we name it. Magnesium. Magnesium. And this one is hydroxide again. And there's how you name those. Okay. Now, this number 2 is going to be a little more difficult. I'll get to that a little bit later. Let's go and talk about a couple other ones, right? Let's look at this one right here, okay? So NO2 is not a nitrate. If you go to your polyatomic ion, NO2 happens to be nitrite. So the last rule we're going to have is any of these acids that end in ITE, that's going to change the ITE into OUS, okay? So we don't use the hydro at all. And this is why it's super important to have your polyatomic ion chart. Anytime you have a polyatomic ion or the anion being an ITE, ITE is going to change into OUS. So this becomes nitrous acid, okay? SO3 for M right here. We don't use hydro. SO3 is a polyatomic ion. We go to our polyatomic ion chart, we find SO3, and we see this as sulfite. Well, sulfite, that's the ITE, that's going to change into OUS, okay? But now we have a little bit of a problem. We can't say sulfus. We don't. There's a little bit of a hiccup in the way we name this one. It's actually said a different way, and it would be sulfurous acid, okay? Sulfurous acid. And so that is the way we name the formulas. Now if we go back to like number 2 here, and we see naming the following acids and bases this way, we're writing the formula for it. We see we have a hydro in front. That means already we have an acid that has no oxygen in it at all. Has no oxygen. So I'm going to put no O2 for this one, no oxygen. Well, if the hydro means we're going to have this right here in front. We're always going to start our acids with an H, right? Chloride, that's Cl. So there's no oxygen in it, HCl, okay? Nitric acid. Nitric, that's nitrogen. Nitric, there's no hydro in front. This does have oxygen in it. So if you go back to the rule up there, you're kind of working in reverse here. So if it's IC in the name of the acid, that was ATE before, okay? So if you look at that, we're kind of going in the reverse. If it's IC, it will now become ATE. So nitric, we're going to start our acids with an H. Always do it with an H. And it's going to be nitrate, and that's NO3, HNO3. Chloric, there's no O2 in that one either. There's no oxygen. And so chloric acid is going to be, well, first we start with our H, right? Chlorine, okay, chloride. Chlorate. Chlorate is a polyatomic ion because ICs reverse back into ATEs, and chlorate is ClO3. So if you look at your polyatomic ion chart, you find chlorate is ClO3, and that's going to be HClO3, and now you've written the formula for chloric acid, okay? I'm going to let you work a little bit at that, and that's just an example on how to do some of these. You should be able to solve the rest with little trouble at all.